And let's go to the next question. Okay. So the next question is question number 9. Okay. When a light beam emerges from water into the air, the average light speed is what? So we have two mediums, water and air, and we're thinking about light speed. So we know in a vacuum, so when there's nothing, essentially just nothing, in a vacuum, we know that the speed of light is represented by the variable c, and it will equal 3 times 10 to the 8 meters per second. So that's in a vacuum. Let's look at what the junior tutor has answered here. So when light beam emerges from water to air, so we're looking at from a denser material to a less dense material, and there's a change in the speed of light as it is moving from denser to rarer. So rarer is just less dense, medium, so the average speed of light increases. This is the property of light that when it enters into denser medium, its speed decreases. When it moves out of the denser medium to rarer mediums, its speed increases. This is called the refraction of light. Light bends when it enters a different medium due to the change in its wavelength. So this is the correct answer. So let's go through and think about what this means. So you can think about the following equation. So the speed in any medium should equal, so the speed of light in any medium should equal the speed of light in a vacuum divided by some index of refraction represented by the variable n. So we know these values for kind of the medium, so n for a vacuum will equal 1. It will be equal 1.0. For air, it will be very close to 1. It will be a little over 1, so we'll just say approximately 1. But it will be a little greater, a little bigger than 1 for air. For water, it will be much more than what it is for air. So we know for water, it will be much greater than 1. We can look up the value exactly, but we don't need to know that for this question. So here we're going from water into the air. So if we increase the n, which is represented by these values, so we had for vacuum is the first one, for air, and for water. So for water, the n, the index of refraction is increased. We know it will be inversely proportional to the velocity of velocity of light in the medium. So Vm will decrease because n has increased, and n is in the denominator, so increasing the denominator will decrease this entire value, and we'll end up with a lower Vm. So we know in this medium, so in the medium of water, the speed will be less than if the n value was lower. So if as you go lower, and so in this direction, as we go lower and lower until we reach the vacuum index of refraction, we will end up with a higher speed. But as we go the opposite direction, so to denser mediums, we'll have a lower speed of light. So looking at this, we're going from water to air. So we know that we're going from a dense medium to a less dense medium. So we know water will be slower. The speed of light will be slower, and then we go into air, the speed of light will be faster. So we can, let's say we have water over here, and then air. We have some beam, and then it gets refracted, so the angle changes. We know here we have n will be a little greater than 1, and then for air, n will be about a tiny bit greater than 1, but it'll be much closer to 1 than water, and that's why we get slower speed in water and higher speed in air. And then we know the average speed of light will increase. So this is the same answer as the junior tutor, and we know that we verified the junior tutor's solution. So here we can say correct answer, great job. And we'll say solution is correct. So